Alright, hi everyone, welcome back to another video. So I'm excited for this one. Again, we're moving on with my final year project. So I've done the majority of like the thought process behind it, and so now I'm just getting straight into it. And in the last video I did like a bit of a demonstration of what I'm going to do and my different setup. And what I've done is I've set the final year project into 4 different phases. So the first of them being the learning phase, which is what I'm in now. Next up, having the planning phase, third being a development phase, and fourth being a testing phase. So I'm looking to complete the learning phase, which is where I'm at now, in this summer holiday period that I have, and then hopefully be done with it and have a really good understanding of what it is I'm trying to do and what I need to do come the start of the year. So I think that's very, very important for me to get done. So what I've done is I've broken the learning phase down into 3 different sections. So the first of it is going to be creating the project itself. So, you know, the solar panel, the charge controller, the battery, the DC and AC outputs, the whole thing, create the whole thing using commercially available products, which is what I've got here, right? So I'm going to do that. And then once I've done that, I'm going to try to do the exact same thing again, but this time using DIY kits. And then once I've done that, then I'm going to try purely just using my own PCBs, my own perf boards, and just basically copying these commercial kits, but doing it completely myself. And so the idea there is that once I've done that 3 times, so I've basically built the project 3 times. One with commercial products that I just bought, the second with kits that I've bought and then, you know, actually physically sold to myself, and the third with kits that I've, or circuits that I've made myself, but just by copying these, right? So my final product, you know, is not going to be these at all, right? It's going to be my own components with my own values decided, you know, each with different resistor, different IC, you know, it's going to be different things basically. So yeah, I just want to make sure I have a good understanding of what it is I'm actually trying to do, really. And so the hope is that once I've done this and I've done those 3 stages, by summertime I should be good to go. So in this video, what I'm going to do is I'm going to try to see if I can get the solar panel working, which is what we've got in here. Get the solar panel, get it charging, or get it working with a charge controller, and just understanding how the solar panel and the charge controller works. Once I've done that, you know, I'll be happy with this video. And then in subsequent videos coming afterwards, I'll literally just keep on adding to it. So solar panel and charge controller first and foremost, and then after that, you know, add a battery, add a DC output, AC output, etc. And so build from there. That's what I'm going to do in subsequent videos. In this video, we're just going to get the solar panel and charge controller, which I think is this. We're going to get them working together. So let's do that. All right, so let's just open up everything. So we've got this solar panel here. If you want, I'll leave a link to everything in the description below. Okay, so obviously I don't need this for now, so that's what. Okay, all right. Well, we'll leave that there for now, anyways. So I need this charge controllers, but what I'll do is I'll just open everything because I kind of ordered like 2, 3 of different things if I wasn't really sure. So just gonna open everything. Again, like I said, you know, I kind of have an idea, and I think I've ordered the right things, but I'm not 100% sure. So. Oh yeah, this is like the battery holder thing. This is cool. I look forward to using this. DIYmore.cc 5V 3A 3V 1A. It says it's the USB charger. Okay, this is some solar power manager. So this is, I think in total I probably paid like £80 or £90 for all of this, maybe a bit less. It's a solar power manager, 5V 1A. They all had various different specifications. So I'm probably going to use this, I think. Maybe not, I don't know. Okay, this is a solar... I don't know if is it a charge controller or I don't know. So this is a solar input and battery output module. MPPT solar charger. So I need to check all the specifications on this stuff, but I might probably use this as well. So yeah, hopefully you guys can see now that I really have no clue what I'm doing. So this is a battery charger again, same one. Or I don't know if it's not the same, but it looks the same. Yeah, I don't know. So this is a 12-volt lead acid battery charger. Overcharge voltage 14.8 volts. Float charge voltage 13.55 volts. Yeah, I don't know. I think that the trickiest part for me is just gonna get the solar input into a battery. That's gonna be difficult. Alright, so again, what's this? Oh, this is actually, look at this, this is actually dirty. It's actually very dirty. Ew. Anyways, I don't even know what it is. I don't know. I have no clue what that is. Gonna have to check the... I got it all off of Amazon anyway, so... So this is some sort of USB connector. Oh, okay, nice. These are the batteries that I ordered. Yeah, these are 2 batteries that I ordered. And this is the USB charger to charge them. That's cool. So these are 3.7 volts, 650 milliamps. And so to charge it, I assume there's some sort of battery charger in here of some sorts. But I'm well excited, man. You know, like the whole kit, if the kit has these tiny batteries in there, you know, and this can run a Raspberry Pi or something, this is exciting stuff, man. I don't know what's in here. AZDelivery micro USB. Okay, so these are 5 micro USB. They like snap, I assume. Right? They must do. Just snap one. Yeah, there you go. So it's some input. So you got the inputs there and the battery outputs there. You'll be excited to understand, you know, how this. Look at that, those little. What is this circuit doing? This is what really excites me. I'm pumped to get to know all of this stuff. This scares the hell out of me. AC inverter module, 12 volts or 24 volts DC, up to 18 volts AC. No, sorry, up to 18 volts AC, all the way up to 220 volts AC. So this scares the hell out of me. I don't want to be messing about with this at all. Look at this chunky thing, man. But basically, you can get different AC outputs from here. So when I designed this myself, obviously mine was going to be a lot smaller than this big chunky thing. I don't even know what this is actually, but I assume an inverter. Look at this giant capacitor as well, man. The size of that. This is so exciting. I'm really pumped about this. So I think this is a smaller one, AC inverter, 40 watt. Basically the same thing there, but I think just smaller, less professional. 12 volts. 12 volts too, and then it doesn't say the AC output. Where do you even take the output from? 12 volts, positive and negative is here. So these are the inputs, and I assume this is the output. A and B, yeah. So these are the outputs there. This is scary stuff. This is going to be so cool, man. I'm really excited for this project. The fact that, you know, like to think about a 16-year-old or a 15 or 14-year-old kid is going to be able to, you know, build this himself, you know, from a kit that, you know, hopefully costs like 50 quid or something, right? Which is cheap. And then, you know, because I've got a lot of friends that are like, oh yeah, I want to get my kids into electronics or into renewable energy and stuff like that, and there just isn't any kits or any, like, people say, can you recommend to me some YouTube channels? And there are really great YouTube channels, but nothing for a kid to learn stuff from. It's all super advanced stuff, man. So this is again a solar charger, I believe, with like a display, 7-second display, and some buttons to do some stuff. I don't even know. Battery and input. So the input comes into here, Huh? Wait, in and battery. In. Okay. Yeah. Input here, battery here. Alright, and okay, now done. So, alright, we've got the solar panel. We've got one charge controller, one inverter, another inverter. Some, I assume these can be considered like chargers. They're like, you know, little micro USB, but at the same, they have micro USB inputs, but they also have other inputs. So we'll put them down as like chargers as well. And then this is like a battery shield. I'm not really sure how this is going to go, but what I would like to do is, these are some huge batteries. I would love it if I can do the whole project off of just normal AA batteries, because then if I ship the product, I don't have to ship it with batteries, and a person can just use their own AA batteries. So that would be good. So this is like, I don't know, what's this? Is it a charger? I don't know. This, I don't even know what this is. We've got ground, VCC and ground, and we've got out here. So we've got VCC and ground, then you got out here, AC, ground, and DC. I don't know what this is. Let's say some sort of inverter, but I don't know. I'll have to check. Then we've got one charge controller again. We've got another charge controller. We've got two batteries. And we've got another charge controller. So, yeah, man. This is exciting stuff. A little USB as well. So all of this for 80 quid, it doesn't seem worth it. But again, I don't know what any of this stuff does. I don't know much about this stuff at all. I don't know how it works on a circuit level. I don't know how it works on a like useful level of actually using it. So again, this is a big learning experience for me, and hopefully, you know, in the next 2.5, 3 months, I'll have this, you know, to the point that I can look at this video and just laugh at the fact that I even, you know, I got this wrong or whatever. So yeah, let's crack on. Still going on with this video because I don't want to just end it here. We'll try and see if we can get this solar panel to work with one of these controllers and get some sort of output from it. So yeah, so let's start, I think, by testing what output we're currently getting now. So at the moment it is 3 AM in the morning here, so there's no sunlight. But I've got some lights, so I should be able to at least produce some sort of voltage. So let's see what we can do. Right, so the first thing we'll do is I'm going to check the voltage of this solar panel. So we'll use our multimeter. Okay, so to read this, you've got one of them is the ground, and then the other one is the positive terminal. I'm not sure which is which, but it won't matter. I believe the center point is the ground. Actually, no. The center point is probably going to be the positive supply. Oh, yeah. There you go. So we've got, so it's the, yeah, sensitive is positive and the outer ring is negative. So we've got about 8.7 volts coming out of it right now. Alright, I think to make this easy, I'm just going to cut this. It's I can always just resolder it back together later, but for now it's just frustrating to use. And I don't believe, yeah, I don't think I need it. So okay, we'll cut this. Alright, so now I've stripped them and I have the positive and the negative more available. So you can see now, I'll flip it over, I get 9 volts, turn it back over, 3.3 volts or 2.5 volts. If I now lift it up, 9.9 volts. So I've got this plastic film on it, which obviously is affecting things, but I'm on 9.5 volts now. And as I lift it up to the light, you can see the voltage increasing constantly until we should be able to get hopefully 12 volts. Boom, 12 volts. Cool, so that's what I was after. So, you know, I can get 12 volts artificially indoors, and this is still with this plastic film on. So let's take this plastic film off, see if we can get any higher. I think we got like 12.0 there, possibly like 12.1. Oh, there we go. So we got 8.5 volts. Let's raise it up, see what we can get. 9.4 all the way up to 12. Yeah, it hasn't really made too much of a difference. I mean, I suppose that's half a volt, right? So that's a fair bit. I'm holding up to the same point now. 12.7 volts. Yeah, so that plastic was affecting things. So that's just definitely a solid 12 volts there, which is nice. Okay, so that's good to know. Indoor artificial light, and I'll just quickly show you my light as well. My desk, and then the light that I'm using is this light here. So just a bunch of LEDs light, and that's giving me 12.7 volts, which is nice. All right, so this is where it's tricky for me. So I've got quite a lot of charge controllers, right? The purpose of this is to take, I don't even know. I mean, what is the purpose of a charge controller? Maybe we should start with that. I see. Okay. Yeah, I mean, to be honest with you, thinking about it now, I really don't know. Is this supposed to come off? I don't know, but I've taken it off anyways. Okay. So I know I've got to put an input into these things. So we've got, for example, voltage in and ground here on this side. We've got here battery in and USB out, USB in, solar in here. So you can see there it says solar input there, 4.5 to 6 volts. So I'm not going to be using, unless, I mean, one thing I could do is I could drop the voltage down off the solar panel, right? I could convert it down into a solid 5 volts or 6 volts. So, but okay, let's not use this one for now. I want to use a solar charge controller where I can actually put the 12 volts directly in. It's just, this one just says V in. Okay, so 12 volt lead acid battery. Input DC 15 volts to 28 volts here. You can see this is 15 volts, which isn't enough for my panel right now anyways, at least being 3 AM. I don't even know what this is. ICL 8038. We've got VCC and ground. Is there any indication of what voltages it takes? I can't see one. And so you can see how, like, you know, already I'm learning. Like, you know, I'm already, and you know, you could give me a book chapter to read on this, and I'm gonna learn way more by doing this. So this is a USB input, battery output. Again, nothing on it though. Okay. Obviously, I can just go to the Amazon listings where I bought this stuff from. So it's alright. So we've got battery here, and we've got solar input over here. Okay, so this is the solar input side here on the left. And we've got MPPT. We've got 5 volts to 12 volts. I don't really understand that there, because so it's given us like these 4 bars. What does that mean? Does that mean I can put 12 volts into this? I think so. So I should. For one, I've seen Great Scott. I've seen him remove these connectors here basically, and then just soldering the wires straight onto here. Which obviously there's nothing wrong with doing that. I could just as well, you know, just push the connectors into there. So I might do that. And then, okay, no, here we've actually got here, you can see V in and ground, and then we've also got the same for the battery output as well, which is really nice. So I can put the voltage input here and ground in here. Okay, so this is probably suitable for what I want to do. And this one here is way more chunky. Looks like there's a lot more going on. Inputs here. Batteries here, proper connectors. 30 amps, but yeah. 250 volts. 30. Okay, so 250 volts AC to 30 volts DC. Yeah, I don't know what this does. Okay, so what I think the best thing to do here is let's first look into what a solar charge controller is. What these, you know, what do these do basically? Let's. I know you need one, but what does it actually do? Okay. And then once we've done that, and we've figured out what this thing actually does, then we'll jump on the individual listings themselves and check which one would be most suitable for us. Whether or not we need another module to drop this voltage down from 12 volts to 5 volts. Whether we need to bring the voltage up, I don't know at this point. So yeah, it's I would say your guess is as good as mine, but you might already know. So yeah, I'm going to jump on the computer first. I'm going to figure out what a solar charge controller is, what it does, and then we're going to take a look at these listings to see their specifications and see which one's the best one for us to use with our panel here. So let's do that. Okay, so it's been 24 hours now, and I'm making some progress, thankfully. So if we take a look at this lovely thing, which I thought was going to be a solar charge controller, it turns out that this is actually a signal generator, and I forgot that I ordered it. I actually ordered this as part of making an AC low voltage output. So you can see all of the potentiometers there that you need to turn. I don't know why I didn't notice that. I kind of just assumed that they were relays, but yeah, this is a signal generator. So yeah, let's pay £6.50 for that. So yeah, let's put this away. I'm a bit bummed out that it's dirty though, but yeah, signal generator. So not a solar charge controller. Let's add in the solar panel, and then let's talk about how we're gonna figure out wiring this thing up. So the simplest way possible to use a solar panel and a battery, which you got here. The simplest way to do it is just to connect the two together. So if I just take the positive terminal in here and the negative in here, then there you go. That's the simplest connection you're going to get. And now this solar panel is charging this battery. So it's literally just simple, positive to positive, negative to negative, and you're done. So there's two problems with this. The first problem is that at night time, when the solar panel isn't generating electricity, then you're actually going to have leakage current going from the battery over to the solar panel. And so that's actually going to drain your battery. Now, that's not going to drain your battery fast. It's actually going to be quite slow. And there is actually still a very easy solution to that as well, which I'll show you now. So if you wanted to stop the battery from draining and going through the solar panel and then leaking, all you got to do is just put a diode in there with the cathode end into the battery, just like this. And then once you've done that, then now obviously electricity and current can still flow from the solar panel through into the battery, because obviously you've got the cathode in there. But now because the diode is there, no electricity now can leave this battery and go back into the solar panel, right? Now obviously this setup isn't useful because all this is going to do is just charge the battery, and if you wanted to use the battery, then now your positive terminal, no, literally in this setup here, no current can leave the battery, right? Because obviously it's got the cathode there. But this does obviously prevent you from discharging your battery when it's charging on the solar panel. So if you had, like, for example, another terminal of the battery here, then this would be a good method that you can just very simply charge your battery here, and then you could discharge it from another output there as well. But yeah, that would be if you wanted to just connect it battery to solar panel. Now, even if you had this, the more serious problem with this is the fact that the solar panel could obviously overcharge the battery. And so depending on how much voltage this solar panel is generating, it could easily, on a hot summer's day, overcharge the battery just like this. And even if you had the diode there, that would not prevent, obviously, you got diode there to stop the current from leaving the battery, but that wouldn't prevent the solar panel from overcharging the battery. And so this is where a charge controller comes into play. And this is what these charge controllers actually do. And so when I started this, I didn't really know what a solar charger was. I've actually used one in a project before, but I know how to make it work, but I don't know what it actually does. So I've done quite a lot of research now, and it didn't take long. It's fairly easy to understand, so that's good to know. So basically, solar charge controllers are voltage and or current regulators. So they keep the battery from overcharging. Now what it does is it regulates the voltage and the current that comes from the solar panel. So you put it between the solar panel and the battery, just like so, right? And then what it's going to do is it's going to regulate whatever voltage and current is coming from the solar panel. And so, for example, most solar panels, they generate, like for example, this is a 12-volt solar panel. Now, it will generate above 12 volts. As you saw earlier in the video, it was getting 12.8 just from my LED light. So on a sunny day, this solar panel could generate 16 volts, 20 volts. Now, obviously, if we was charging, at 20 volts on a midsummer's day, the battery is going to get overcharged very quickly, right? So this battery here is a 3.7 volt battery. So it's not going to be long before this battery gets overcharged by this solar panel, right? So what this charge controller is going to do is it's going to take the higher voltage that comes from the solar panel. So let's say, 12 volts, 14 volts, 14.5 volts, right? And it's going to drop it down to whatever voltage the battery needs. So here, this battery is going to need 3.74 volts, right, to charge. So we're going to take this 12 volts from the solar panel, we're going to drop it down to 4 volts, and we're going to use it to charge the battery. Now, what's interesting is that these charge controllers will actually vary the amount of current that is going in to charge the battery, depending on how charged the battery is. So an easy way to think about this is that when you plug your phone in on charge, then when you start charging your phone, and let's say your phone's at 12%, it's going to charge rapid up to 70%, and then it might slow down a bit and go up to 90%, and then from 90% it's going to trickle charge over to 100%, and especially when your phone gets like 98%. Apparently, if I'm not mistaken, I'm pretty sure phones don't even get to 100% the way that they're designed. So that's a voltage regulator there, making sure that you don't overcharge your battery. And this is the same thing what a solar charge controller does as well. So it's going to base the amount of current going into the battery based upon the battery's current voltage. Again, they're super simple to wire up. So we've got, for example, here it says solar in. So all I've got to do is just connect this battery into this input here, which they're not the right connectors, but basically what I can do is I can do it here as well. So you see how we've got a V in, ground, battery. So if I just connect ground and battery like this, right, and then the input from the solar panel, V in and ground like that. I'm not gonna do it right now. And then that will literally there now start to charge the battery from the solar panel, but the solar charge controller will constantly keep on checking what voltage the battery is at. So let's go into a bit more detail about these charge controllers. So I've got a few of these. I've still got this one as well, although I don't think we'll be using this one, but it's okay. So what I'll do is I'll be going into, for example, how like the different types of solar charge controllers now, and then we'll take a deeper dive into the specifics of each charge controller, because these charge controllers are all very different. You can see that from the size and their design as well. So there are 3 types of charge controllers. The first is just going to be a basic charge controller which uses relays. So you can see here with this giant relay, but a basic charge controller will use a relay, and what it will do is it will control the voltage in 1 or 2 steps. And what it does is it disconnects the solar panel from the battery once a certain voltage is reached. So it's super basic. All we're saying here is that once 3.7 volts is reached, then disconnect the battery from the solar panel. So if you've got a solar panel and battery connected here, then all we're saying is we've got a charge controller right here, and then we're just saying activate a relay or a switch, disconnect, and the battery's now no longer connected to the solar panel. And then obviously once the battery voltage drops below that threshold voltage, then again relay, switch, closes, and then now the battery and the solar panel are connected. So this is a super basic way. The only problem here is that you're going to charge your battery at whatever voltage is on the panel. So if you're getting 14 volts and whatever milliamps, then that's the rate that your battery is going to charge at, and you can't do anything about it. It's going to go at whatever rate the solar panel goes at. Now the second type of charge controller is called a 3-stage or PWM, pulse width modulation charge controller. Now instead of the charge controller just simply outputting a steady voltage to charge the battery, so like I said, if we connected these two together like this, then what we're saying is that 12 volts is just going to go straight into the battery and charge it at a steady rate. So pulse width modulation is actually going to output the voltage and current from the solar panel in short pulses and bursts, and so it's going to vary those pulses and bursts based upon the voltage of the battery. So it's going to constantly keep on checking the state of the battery to determine how fast to send the pulses of charge, or for how long the pulses of charge should be. So when the battery is fully charged, the charge controller will then send out like short, tiny pulses every few seconds just to check if it's still fully charged. And then, for example, when the battery is fully discharged, and it's, let's say, for example, this was down to 2.5 volts or something, then the charge controller will send very long continuous pulses, and it will even just, for example, go into fully on mode, whereby it will just allow the solar panel to just dump as much voltage and current into the battery as it can. So the charge controller is going to keep on constantly checking the voltage of the battery between each of the pulses. So with the shunt and with the transistors and relays that are used in the first type, the basic 1 or 2-stage controls, that's just waiting for a threshold voltage. So you're just saying once 12.5 volts is reached, click, either click on or click off. That's all that's doing. The PWM, between each pulse, between each cycle of pulse, then it's going to check what's the battery voltage. Should we increase the amount of pulses or should we decrease it? Should we be more on? So for example, the panel could be outputting 12 volts, and the solar charge controller, the PWM one, what it's going to be doing is it's going to be saying, okay, just send 50% of that into the battery, and so you're going to be getting 6 volts. So if it could do 12 volts at 1 amp, then 50% is going to be 6 volts at half an amp, and so that's how PWM works. Now, the downside to a PWM charger is that they're short pulses. If you imagine the charge controller constantly switching, small pulses on and off, that can create noise for other surrounding equipment. And so the third type of charge controller is going to be an MPPT charge controller. So this gets a little bit complicated, but stay with me. It took me 20 minutes to understand it. So if I can do it in 20 minutes, you can do it in 2. So an MPPT charge controller outputs the best voltage possible, such that the highest amount of amps can go into the battery. So what the MPPT charge controller is doing is it's going to calculate what is the best power that this panel can output to charge this battery. So that doesn't mean, for example, okay, we're 50% charged, so we're going to pulse out 50%. That was the PWM one. With the MPPT, it's going to calculate, okay, based upon what's the maximum amount of amperage that we can get going into the battery. And so it's basically a complicated DC to DC inverter. What it's going to do is it's going to take a DC input from the solar panel, it's going to convert it to a high frequency AC signal, and then it's going to convert that back to a different DC voltage and current. So just as an example, if the panel is outputting 12 volts, let's say 10, we'll go 12. If the panel is outputting 12 volts at 1 amp, then what this solar charge controller can do is it can then convert that to AC and convert that back to DC, but be in a completely different voltage and current. So for example, it could switch to 6 volts and 2 amps. So you see what it's done there, it's taken 12 volts at 1 amp and it's ramped up the amperage and lowered the voltage. And if you think about, for example, a battery like this, you got 3.7 volts. You don't want 12 volts going in here. That doesn't make sense, right? What you want to do is crank up the amount of amperage and get it to, so you can see 650 milliamp hours. Get it to the maximum amount of amperage that you can get into this battery. And then that's going to cause the battery to charge rapid. And so these MPPT charge controllers, they're amazing. You just need to keep in mind, when it comes to, for example, MPPT, it stands for maximum power point tracking. Maximum power point tracking. So keep in mind that power is equal to voltage times current. So the MPP, which is the maximum power point, is the point on the graph. So if you imagine, for example, actually I'll show you here, if you got current on one axis and voltage on another axis, power is going to be the voltage times by the current, right? So when the voltage is 0, the current is going to be equal to 0. And when the voltage is high, close to its maximum, then likewise the current will also be high. There's going to be a certain point at which the voltage is too high now, and then the current is going to drop, right? So you couldn't put 2000 volts through this. That wouldn't work, right? So the MPP is the point at which the product or the multiplication of the current and the voltage from the solar panel is at its greatest value. And you can see that here with this graph. It displays it very well, where you can see you've got that point whereby the voltage is still high and the current is still high just before the current starts to dip. And then at that point there, you can see where the maximum amount of power is being reached. So I didn't really do that justice. It makes a lot more sense in my head, but I think I've got it, and hopefully you do too. It's just important to know that the MPPT charge controllers, they're using an algorithm. So it's a DC to DC converter that uses a maximum power point algorithm to work out how much current should be going into this battery. And that's all it is. It's just a very clever computer, basically. So it's important also to know as well that solar panels are most effective when it's cold, and when they're hot, they're less efficient. So the colder the solar panel, the more efficient it's going to be. And also likewise, when the charge controller is damaged, when the battery is discharged, then likewise the MPPT is going to be very effective at charging a discharged battery. So it's probably important to mention at this point what is a boost and buck converter. So you're going to come across these terms a lot. It kind of makes sense, you know. Bucking is to to buck something, and boosting is to boost something up. So a boost converter is a converter in which the input voltage, which is obviously DC, is going to be lower than the output voltage. The output voltage is higher than the input voltage. So if you have a boost converter, then what we're saying is that we're going to put a DC signal into it, and we're going to get a higher DC output signal, right? So in our example, in this example that we got here, the solar panel, the input voltage from the solar panel is lower than the battery voltage, right? Now, in this case, it's not the case. Our battery voltage is actually lower at 3.7 volts versus our 12 volt panel. So we wouldn't use a boost converter here in this situation, because we're not trying to take our 12 volts and boost it up to 24 volts. So if we had a 24 volt battery, then we would be using a boost converter involved in here to boost our voltage from 12 volts up to 24 volts. But in our instance, we got 12 volts our input, and our output needs to be 3.7 volts. So what we do there is we use a buck converter, bucking the voltage, and it's going to convert the DC input voltage and make it lower to match the output voltage. So what we're going to do is we're going to take our 12 volts and we're going to buck it down to 3.7 volts to go into our battery. And again, it's important to know that the MPPT algorithm, which is just the maximum power point algorithm, the software and the hardware that's doing all of these MPPT charge controllers, that whole algorithm is effective with both a boost converter and a buck converter. So again, that's important to know because we're going to be using that later on. So now let's talk about the specifications of these charge controllers, or in this case, it's not even a charge controller. So I suppose maybe makes sense to start with this. So the title of this is a TP4056 micro USB 5 volt 1 amp lithium 3.7 volt L-ion battery charging board module. So basically, I should just be able to put in an input voltage into here, this side here, and then just connect the battery onto there. And it's possible, although I'm not sure, I'm gonna give it a go, that I might be able to just charge the battery from just using this board. Now, the only thing that you need to obviously focus on is what is the maximum amount of voltage that this thing can take. I'm gonna hazard a guess and say that this little board can't take 100 volts. So let's go through the description of it. So it says that over discharge protection, it keeps your battery from being discharged below 2.4 volts. So this is going to cut off the supply of the solar panel to my battery once it gets to 2.4 volts, which is perfect because that I don't want to drain my battery, obviously. And then it also has overcurrent and short circuit protection. So it's not going to allow more than 3 amps to flow anywhere, which is obviously a good thing. And at the same time, it will disconnect the battery from the panel once it reaches 4.2 volts. And so as you can see, we've got 3.7 volts there. So this battery using this board is never going to go below 2.4 volts, and it's never going to go above 4.2 volts, which is, you know, this tiny board is actually perfect. So now I just need to find the input voltage, which when I had a look through, I couldn't really see anything. And so there's no mention of what the max voltage is. And then also I'm a bit concerned because it did say on the description lithium ion, lithium 3.7 volts L-ion battery. So I'm not entirely sure if this battery in this combination is going to go. Again, you know, this is part of the learning process, but I think I can use this, at least at this point. So I'm going to give it a go anyways, but at the moment I think I can use this when it comes to charging the battery. So hopefully, let's hope I can. So let's take a look at the others. All right, so we did the smallest one. Let's try the biggest one. Now, like I said, obviously, I really don't know what I'm doing here. So I've picked up a bunch. I don't know. This one, you know, is huge. It really is. Like, compare that to that. All right, so the listing for this one is called the Battery Charge Protection Board. Charge Protection Board, auto on off. I assume you're using this relay. charging protection controller module, 12 volts and 24 volts, 48 volt batteries. So I'm guessing that this is not going to be suitable with my 3.7 volt battery. I may be at a little bit of odds here because obviously I've got a 12 volt panel. So this 12 volt solar panel is probably going to be alright with this. Let's just have a look. So they've got here, the protection board supports power supply TV surge protection. When power on, power supply has an instantaneous high voltage and TVs can reduce instantaneous high voltage to protect the circuit. He says use it as a voltmeter, save parameters when power failure to avoid repeat settings. If set start and stop voltage to a minimum, less than 6 volts, it can be used as a voltmeter to measure 7 to 60 volts. So our solar panel's 12, so that's within that input range. So I can put a 12 volt in here. So it's got working current at 12 volt power supply, which obviously is our solar panel, a charging current of 130 milliamps, and then a standby current of 5 milliamps, and default start charging voltage 12 volts, default stop charging voltage 14.8 volts. And can I adjust this? What is this? Is this a capacitor? That's a capacitor, right? Yeah, that's a capacitor. So we've got a set increase and decrease buttons there. Oh yeah. We've got no reviews as well. I don't know why I bought a product with no reviews. Okay, I'm a bit lost with this one. Definitely we can take 12 volts in. It's just a question of what about the battery? The output voltage. So it says, yeah, no, this isn't going to work. I've just read it here. It says it can charge 6 to 48 volts lithium battery. And so obviously my battery here is not 6 volts. Now, there is the option that obviously I can just go and get a larger voltage battery. And I may well do that. I haven't decided at this point. Again, like I said, this is just a learning stage for me. And already in this video, I've learned a bunch. And I'm sure any of the guys in my year at my uni, for example, they wouldn't know any of this as well. So if they watch this, they would have learned a bunch as well. So if you're learning a lot, drop a like, man. It's my likes don't get much love. All right, let's move on to the next one. We'll go with this one. This one looks really nice. I like this one. This is the MPPT one. The DFROBOT Solar Power Manager, 5 volts. So that last one, I'm not sure what I paid for it. I'm thinking it was like £6 or £7. This one here costs £9.90, so it's the most expensive, I believe, of all of them. So it's the DFROBOT 900 milliamp MPPT solar panel controller. It's a solar power manager module for 5 volt solar panel. So already I'm kind of at a loss there. Now, I can obviously take the 12 volt input from the panel and drop it down to 5 volts and put it into here, which may be an option, maybe something to do. So Solar Power Manager 5 volt is a small power and high efficiency solar power management module. So what does it have on the board here? Yeah, look, you can see here it says solar input 4.5 to 6 volts. So it's literally specifically just 5 volts. And then we got battery in here, and then it looks like we've got 3.7 volts. Interesting. Okay, so we've got 3.7 volts charging there. You can see the 3.7 volts. So more than likely, I'll be able to connect this. These aren't the same connectors. But I could remove the connector and just solder it directly to it. But so this will charge 3.7 volts fine. The only issue is I need to get 5 volts at this input and not the 12 volts that I have. So it's just a question of whether or not I have a DC to DC converter. And if not, then I need to get one. And that would be a solution. Because I think this one, I don't know how this is going to charge a 3.7 volt battery, but this one will definitely charge a 3.7 volt battery. As you can see there, 3.7 volts at the bat in point there. I assume they're both battery inputs actually. Yeah, they both are. They're just two different connectors that they've given us, which is interesting. What's this? So this USB is 5 volts, 1 amp USB output. That's very clever. So you can take a solar input there and then it will give you a nice steady 5 volt, 1 amp output there. That's really nice. We've got some jumper pins as well. Ground, 5 volts, off, on, off. I'm not sure what that is. Is that just a 5-volt output? I'm just wondering if it can take in higher than 5 volts. Because if it can take in 12 volts, that would be more than ideal, right? Yeah, input voltage 4.5 to 6 volts. So what we need is we need a remember we have the buck converter and the boost converter. That's why I mentioned that earlier. So we obviously don't want to be boosting the voltage because we're going to be getting 12 volts from the panel. So we want to be bucking the voltage down to a 5 volt, 6 volt level. Interesting. Okay, so let's move on from this then. So this is a good product for charging the battery, but not for taking the input. And again, you know, this is how I learn. You know, if I would have sat down and spent 2-3 hours looking through the listings and trying to understand it, to be honest, I wouldn't have done that. I just wouldn't. Give me the product in my hand and I'll learn it. That's how I am. Alright, so this was the more expensive one. This was £7, I believe. So we've got battery charger controller, 3 amp, 12 volts. That's good. Okay. 1 to 1000 amp hours, accumulator, acid battery cell storage, battery charger module with terminal. So it's saying that you could, there's 2 pictures of it, one with these terminal pins, one with them soldered, removed. So the fact that it's a 12 volt lead acid battery is a no-go for me, I think. This is probably to take a 12 volt input and just, an input of, it's a high input. An input of 15 volts to 28 volts. And then to put that into a 12 volt lead acid battery, which I don't have, and it would be, imagine a final product shipping with a lead acid battery. So this is probably going to be a dud. So it's designed for charging 12 volt acid batteries with trickle charge, constant current charge, overcharge, and float charge modes. It's recommended to go between 16 and 25 volts DC, and it will charge up to 14.8 volts at 3 amps. I'd like to give these things a go. It's just be a shame, you know. And again, if I don't use it for this project, I can always try and use it for another project, right? I really want to get really good at solder anyway. So, all right, let's take a look at the last one now. This is the one I had the most hope for. So we've got the ZHITING. That's just probably the branding of it, but I've seen this all over the internet. CN3791 solar charge controller board, MPPT, 1-cell LiPo battery charger, 12 volt solar panel, perfect. Charger regulator control module, JST PH 2.0. No idea what these things mean. Auto recharge for battery with cables. Okay. This is a maximum PowerPoint tracking MPPT solar charger for single cell LiPo batteries. I'm pretty sure this is a single cell LiPo battery, and I'm pretty sure this is going to be able to charge it. I hope. This is why I saved it to last. So the output voltage, fantastic. The output voltage, nominal 3.7 volts, full charge 4.2 volts. What does that say, baby? 3.7 volts. Yes. And the input voltage, 12 volts. Let's give it a go. This is exciting. So these connectors obviously aren't going to work, but we should just be able to just cut them and solder it all to there. So I'm going to give that a go, man. Let's see if we can charge our battery. Now, how would we know it's charged? That's another question. Let's see if I can take the battery, the voltage of this battery for now, and then see if we can get it increased using the solar panel. This is exciting. So just need to probably cut off, pull off this connector if I can. Okay, I can't pull it off, so I'll cut it. So cut these and then solder them to there, and same again with the input, and then well, I'll check the voltage now first. Actually, let's do that. All right, so I've got my battery here. So let's go into our positive terminal here. What voltage we got? So we got 3.9 volts. So the battery is fully charged, which is nice. So let's cut this and short it out. No, I'm joking. Don't do that. So we'll cut it. We're at 3.9 volts now. We'll cut it. We should be able to charge it up to 4.2 using our charge controller. We'll cut this. Need to be a bit careful here not to short them out, because to be honest, even as I cut them like that, technically I'll short them across this. So yeah, you need to be careful doing this. No, okay, alright, so I'll cut them both here, I don't know. One at a time, cut them. Even though I kind of shorted them a bit. Alright, so nice chunky wire. Nice chunky wire. Okay, that's a proper thick positive and negative there, which is good to see. I've never done this before, so I'm actually a little bit scared that I might heat up the battery or something. It's actually not stuck very well, really. Okay, well, that's a big enough blob. Hopefully, hopefully it sticks. Let's just give it a little pull. Okay, well, yeah, that's stuck there. This is a great learning experience. I'm learning a bunch. I actually just shorted the battery there. Damn, man. This is a tough. Because the terminals are right, like literally, they're right there. Like, how do you not short them together? Oh, crap. A whole bunch of smoke just came out. Oh, yeah. I think this is toast. It stinks as well. Once you get the magic smoke coming out, you're finished. I didn't even see where that came out from. How would you do this? How is it clicking? I felt like I heard it click there. I have no idea. How would you actually, like, how do you solder that together without it touching? Like, did it touch at the back there? Is it worth me even continuing at this point? I saw an LED light up over there in the middle. Oh, yeah. What do we do? This is where I can't wait in future to live stream. Like, if I was live streaming right now, I'd have someone that had a lot more knowledge than me. Well, that's in there, but they're so... The terminals are so close together, man. If they touch for a second, you're shorting out a battery. I think, okay, maybe what I should have done is I should have just wired jumper cables there. So let me do that now. If I solder in a jumper cable first without it being attached to a battery, that would have solved that problem, I think. Yeah. But there you go. See, you live and you learn. So let's do that. And again, like I said, please, if you are learning from this, you know, if you just watched this and you was like, oh crap, what does he do from here? And then now you're like, oh yes, that makes sense. You've just learned something as well. Leave a like. You know, it's free. The thing is, my videos don't do that well in the algorithm. So every little helps. I'm hoping to document my whole process here of making a product start to finish. And so hopefully there'll be some good content coming. So if you haven't subscribed, subscribe please. Again, as far as I know, you know, once the magic smoke is released, you're not getting this thing working again. So this is more of a pipe dream now. Okay. Well, moment of truth. We're either gonna get a really bad short here, and this battery is gonna pop. Damn, man. I don't want to do it. Crap. Mate, this is just 3.7 volts. Like, I'm not even playing with anything crazy. Let's use pliers to touch them. I don't think they're gonna short out. But you know what? It's just like what I know about myself. I'm always doing. Okay. No sparks or anything. Mate, these connections are too close on this board, man. So That's one thing to note down, that if I do design my own one of these, you know, we need the we need the battery connections further away from each other, people. This is too dangerous. Okay. Now I would also just like to test the voltage as well. I'm just a bit concerned that it may have dropped from a short or whatever. I don't know. Again, you know, before you leave a comment down below calling me an idiot, just bear in mind that I really don't know what I'm doing at all. The whole purpose of this is not to teach you how to do this. The purpose of this is for me to learn, and for, you know, if you already know and you're calling me an idiot or whatever, then obviously these videos aren't for you anyways. These videos are for people like me who've got no clue what they're doing. So voltage is still 3.91. Yeah, 3.91. I can't keep it stable for some reason. But yeah. So that thing, the short that I caused and the magic smoke being released didn't cause a drop in voltage, which is nice. So let's just try and solder these two together then. I don't have any confidence that this is a good idea. So I've decided to risk it all for a chocolate biscuit, and I'm just gonna tin these, and I'm gonna see if I can just connect the solar input straight to the controller. I think it's gonna be quite difficult for me to even difficult for me to tin these, but yeah. And this is why I've been trying to get as much soldering practice as I can. Some people consider like those electronics kits that I was doing to be useless, but I don't at all. In particular, the Bluetooth kit that I just did was amazing. That Bluetooth speaker kit was fantastic. So yeah, I don't consider this to be a waste at all. I mean, I feel like my soldering skills have improved big time. Although it's not necessarily showing it here today, but that's okay. If you want, leave a comment below and let me know where if you think this is toast or not. Now, so we're going VCC here. Okay, and then ground. Okay. Oh, smoke's coming out again. Ah, oh, crap. Why? I don't understand. What happened now? Yeah, something's just burnt away. My camera wasn't even in focus. Okay, so I connected the VCC and then it just started to burn away. And I'm not even sure why. Because what I don't understand is the two middle inputs there are both ground, so that should be fine being connected. But as soon as I connected the positive supply of the solar input, it just immediately started to smoke up. Okay, I'm just gonna risk it, you know. I'm gonna put okay, so ah, crap. You're like shorted and sparked out somehow. I don't understand it, man. I think we're gonna have to call this one quits, because there's no way that this charge controller is working, and I really don't get what the sparks are for. I'm assuming it's the battery and the ground connectors, but I just don't know. Alright, so what I'll do from here is I'm gonna cut this ground on this battery. Let's cut it there. Okay, and then cut this here. Okay, so hopefully our battery is still fine. Let's check the battery. And then this, okay, well, the solar panel, we'll try to preserve the solar panel as well. This charge controller is going to be toasted, I think. I can't see it surviving that. I really don't get it though, because literally you can see the ground, the two grounds are there. Probably the best thing for me to do, I think, is purchase another one of these and just go with the connectors. I don't know what these connectors are called. Figure out what these connectors are called and just attach, you know, two connectors to it and just go that way. These four, it's not working out. And there's no way. Surely, you know, that was like 3 or 4 sparks. I can't see it surviving that. You know, from what I know about ICs and all that, this is gonna be toast. So, all right, I'll scrap this. I'll purchase another one. Let's just wrap this video up now, just by testing to make sure that my battery and my solar panel are still okay. So let's do that. Again, you know, I think it's been a good learning experience. I would also like to set the precedent here now that, you know, over the next year when I'm planning on doing, you know, probably 200, 300, 400 videos. You know, I'd say 200 videos. I'm planning on doing like 200 videos on this final year project. And so if I do 200 videos, you can imagine as a kid I'm not a kid, I'm 29 years old, but, you know, as a guy who's learning, still 3.91. Okay. So our battery's still good. Nice. But yeah, so as someone learning this stuff, you know, I'm not always gonna be able to. So does that say 9 volts? Yeah, 9.4 volts. So the panel's still working fine. Again, you know, I'm not even using the other bright lights that I was using before. I'll show you the lights I'm actually using. You can see them kind of in the reflection there. Yes, I'm just using these lights, literally just, you know, dingy little LED lights, and I still get 9.4 volts. So unfortunately, this little board's going to be toast. I think I actually paid a fair bit of money for it. I actually did have IC Station, who sponsored my Bluetooth speaker kit, offered to send me one, and I said no, I wanted a different one, so I might have to contact them back. And I was like, no, I mean, I'm not going to wait, because it takes 2 weeks for them to ship, so I'm going to order one of these off of Amazon. I'm going to get the connectors and attach it to here. I probably need to extend the wires on my battery as well, because I'm going to run out of space if I make another mistake. So yeah, tough video, or tough ending I should say, but regardless, I've learned an absolute bunch. Coming into this video, I didn't know anything. So yeah guys, if you enjoyed it, leave a like, subscribe if you haven't, and I'm gonna carry on. You know, in the next video, hopefully we'll have some success. Take care guys.